Hi everybody, and welcome to VintageElectronicsGeek.com. I'm your host, George. No, Jack. You know that. Just seeing if you're paying attention. Just a quick announcement. Just want to say happy holidays to everybody. Hope everybody has a grand one. Whatever it is, make it a big one. With that said, I need to let you people know, my fans, my friends, stalkers, whatever. The holidays here are upon us, and because of such, I am going to take a extended vacation time, and I could be gone, oh gosh, a couple of months. Well, I'm going to be gone a couple of months. There's no ifs, ands, or about it. And then, of course, when I get back, there's going to be decompression time. So what I'm trying to tell you in a long story short is I'm not going to be too active as far as posting videos are concerned. I do have a bunch of older videos that I do have in the queue, and they will be posted every couple of weeks maybe. And so that's where I'm going to be for the time frame. Just in case you get worried, just in case you get lonely, don't fret. I'm here for you. Now, as far as me and you are concerned, I'm taking my laptop, so I will be able to stay in contact, and I'll be able to watch your videos, and I'll be able to comment as such. It's just on my end, the posting is going to slow down somewhat. When I get back, then I'll resume back into posting. With that said, let's move on to the topic of today. Today's topic is going to be on my new oscilloscope, which is a Tenma 72-6547. It is a 27 megahertz scope. Of course, that's not what you're looking at. What you're looking at is my multimeter. Let me take you on a quick tour of my workbench. Here we go. Stand by. Brace yourself. This might get exhausting. We're going to start off over here. Right here is the edge of it, where the oscilloscope, where the meter is. And then we're going to go this. Ooh. I hope this ain't too fast for you. Stand by. That's it. It's over. That's my entire workbench. Outside of what I have up here. Not a lot. Tiny workbench. Why am I showing you all this junk? Well, because of my new toy, the oscilloscope. And because of such, I have no room on my workbench, as you just saw. My workspace now is confined to just this little tiny area. I had to put my new oscilloscope right there. Alright, the story on this. Trolling eBay, looking at oscilloscopes, trying to figure out what's out there and why is it out there. I've never owned a oscilloscope. This is my very first one. I did use them back in college, in the 1740s, and of course it's been quite some time ago. I actually have no real use on them, so I'm going to be learning how to use an oscilloscope essentially from the ground up, and I'm going to take you on this crazy ride with me as we go. You'll probably see me do things that I shouldn't ought to do, but reason I bought this as opposed to a smaller one, which I'm going to buy next year, the price. I saw this posted for not 100, not 200, but that's right, $10. 10 whole dollars with $16 and some odd cents shipping. How could you go wrong? I figure it'd be great to learn on, and if I blow it up, I blow it up. And no big rip. I bought this one day, the next day I got it. It was lightning fast shipping. Amazing. I just couldn't believe the speed to it. Anyway, let's carry on. The oscilloscope was set up as was sold as is. Don't know if it worked. Blah blah blah. I figure for the price, I've wasted more money on cheaper junk, so why not? Brought it home, played with it for a few days, figured out how to get it to do pretty things. And so short story long, it worked. So let me show you what we got going on. Of course, I ain't got nothing for a pointer, so I'll have to use my finger. We have the main scope right here. Intensity, focus. Intensity is the brightness. This is a 2-channel scope, so we have our uppy downy for channel 1, uppy downy for channel 2. We have our ×1 ×5 button. We have our channel 1, channel 2, or both channels with an add button. We have our normal inverse. We have our trigger, our scope, our plus minus button, our position button, time 1 times 10, a variable with its switch for calibrate and variable. We have our division, and then we have our band spread button there. We have that for channel 1 and channel 2. We have normal, which has auto, normal, TV vertical, TV horizontal. Hope my light's bright enough so everybody can see. We have our times control here. Up underneath we have our AC ground DC for channel 1, AC ground DC for channel 2. We have our trigger source, vertical, channel 1, external, and line. We have ground, we have our input for channel 1, input for channel 2, and then our trigger source, and then we have another probe source right here. Have a couple other plugs on the back. I don't remember what they are. I meant to do a complete walk around on this, but I got excited and I just needed to stab it in its place because, as you saw, my workbench is tiny and it was consuming up the whole space, and I couldn't move on. It is missing the handle, no big rip. It has some scuffs and even has a little dent, no big deal. I got a little piece of wood up here to prop it up just a little off the desk. One thing I would like to ask from you guys, as some of you know, I could find pretty much anything on the internet. I have, I'm pretty talented at that. However, this escapes me. There's just very few, and few I mean 2 posts that I find on it. One is from 2005, the other's from 2009. I don't know exactly how old this is, when it was made, what it sold for. From what I understand, it was one of their more inexpensive models. By that, it sold for around the $900 price range. So I am looking for an owner's manual. I am looking for a service manual. If you guys know where I could acquire one, I would appreciate that immensely. This has also a component checker on it, which is really cool. So let's dive into that and let me show you that. And what I mean by component checker, some of you who own scopes are already aware or know what this does. However, for those of us who are new to this, well, check this kind of cool things out. I would imagine in its day, this would just be a fast way to touch a circuit, a component in line, and it'll tell you if it's opened or not. That's the way how I'm reading it. Now there is a caveat to that, because if the values are too high or too low, I notice it don't read. So here we're going to put a capacitor in line, and so negative to negative, positive to positive, and you got that big O on the screen. Now I did have one capacitor that I actually saw that actually kind of trailed across the screen, and the bandwidth on it was fatter. It wasn't so defined as that is. And I don't really have any buttons per se that would change all that. It is what it is. It's kind of cool. Those that are familiar with this, please chime in, let me know. I don't know, like I said, this is my first time ever playing with one, so I got a lot of learning and I've watched a lot of videos. Let's put a diode in. We'll put negative to negative and positive to positive, and blammo, you got an upside down L. What happens if you put that in backwards? Well, let's find out. Well, you have a backwards L. Okay, enough of that. What about a resistor? Let's try a resistor. And there you go. Now on this, I noticed that the higher the lower the value of the resistor, this line actually will rotate as such. What happens if it's a dead short? There you go. Feed up. I haven't played with a lot of other components to see what they look like, what they do, but that's the basis of it. Now, as far as the scope is concerned, let me hook up my frequency counter. Let me point you to my frequency counter, or I'm going to show you my frequency counter, and I'm going to hook up I'm doing this looking not at my big monitor. I don't have that hooked up. I'm going to hook this up to my signal generator. And you can see right there is the frequency that we're at, 439 megahertz. So we're going to leave it at that. Point you back down to scope. So positive to positive, ground to ground. And swing that back into place. Alright, so like I said, I'm still learning nomenclatures and everything like that. I believe that's 50 volts right there. And we're in a, oh, there we go. Now we're in a times 1. Let's swing that down, try to get, alright, so now we're going to swing the time over somewhere. Well, this worked out completely different yesterday when I was working with it. Oh, you know what? It's because I have the signal generator set up in RF mode. Let me switch it over to modulation mode. Okay, well, it's apparent that I suck at this. Let me pause the video and let me figure this out. Okay, I'm back. I figured it out. What happened was when I was busy talking to you, I hooked my probe lead up to my frequency counter, and that's why I wasn't getting anything. Once I figured that out, mainly because I looked down and I saw my signal generator not plugged into anything, it's like, I am a dork. As you see, we have a frequency there. Where I'm at, I don't know, because I was also adjusting the signal generator. But we're somewhere down around 170 kilohertz or thereabout, 180 maybe. And so that is frequency. Now, we can adjust that. And get some really cool looking things there. Adjust the trigger, and I would imagine you adjust the trigger where it's dead on as such. And I would imagine what we're looking at here, my signal generator is in modulation. We're going to have the primary carrier, which is this, and then all of this lines inside is the audio that the signal generator is modulating. Let's turn that off and go straight to RF and prove that theory. And there you go. That is straight RF. So now if we change the frequency on the signal generator, you should see those bands as we're increasing. You can see that the frequency is going faster, just as you would expect. And so slow that down, of course. Go to your times. Kind of looks like a sawtooth, don't it? Whereas before, let's see, and that's it's about 550 kilocycles right there. And if we scroll all the way down to 170, we get something that looks like that. Not a sawtooth. And so if we go up, and if we switch that to modulation, and then we'll change frequencies. Here we're at 1.6 megs, and then we're going to go higher, all the way up to 15. And as you see, now we have to make some adjustments. So definitely can see the bandwidth. You always see it on paper, and now you get to actually see it in person. That's kind of cool. So anyway, straight RF without the modulation. Now if I switch this over to audio, that should be a 400 hertz tone. Unfortunately, my signal generator does not produce that. I need to overhaul it. It produces like around 350. So I'm thinking that's not too bad for, you know, $26. Again, to start off with, figure out what it is I need, what it is I want. Now, one thing that's really interesting about this 20 megahertz scope is, well, just that, 20 megahertz. Now, if I turn this over to RF, actually, let's go to modulation. And what I want to show you is not these cool, pretty little patterns, but the fact is that, let's see, we're right now on frequency of about 1.9 megahertz. Is the fact that if I was to try to get my arm in your way, go up a couple, that this goofy thing still reads. Now, it may be my ignorance, but it could also be harmonics, or it's real. So here on frequency we are, of course my signal generator is old school, tube type, so it's not digital. So we're on band E. Oh, okay, we're still within scope. That's just at 1.7 megahertz. So let's scroll on up, and you can see that it's changing. Right there is 29 megahertz, and that's roughly 30 megahertz or thereabout. I have to put it on the frequency counter to get the exact frequency, but you can see that this thing is still reading. Again, I don't know if that's harmonics or if that's fact or fiction. But it is doing something. Now if I switch my signal generator up to 61 megahertz, look at that. It's still reading. Again, you tell me. Those with experience, you tell me. What am I looking at? Can a 20 megahertz scope really read 61 megahertz? See, as I drop the frequency, that it changes. So, and that's modulation. And that's RF. Now my generator don't pump out a lot of juice, but the thing is, you could see a pattern come out of it. Yeah, you can see that it's tuning there. So let me leave that. Let me leave the signal generator right where it's at. Let me aim you up to the frequency counter, and let me pull the generator off the scope and put it onto the counter, and let's see what we got. Like I said, the scope's not too terrible powerful, but it is producing something. I have new tubes for it and I need to rebuild it. I got new parts coming in for it. I don't know why I said scope to signal generator. Anyway, you get the point. Point is, I guess, 26 bucks is not bad. Tell me what you think. Anyway, again, if you have any information about this scope, documentation would be awesome. Let me know. Hit me up. I would appreciate that. It'd be kind of cool if you can get those little patterns that look like, you know, heart monitor going. Alright, so I've got that on the signal generator. I haven't changed the frequency from what it was on the frequency counter, but you could see something is there. And if I change, yeah, there we go. Now you see it changing. Alright, thanks for watching. We'll catch you in the next video. Take care. Happy holidays.